everyone, welcome back to my channel. Today we are continuing our journey into the world of networking with a practical CCNA lab. But before I begin, I wanted to thank you all for your support. And I would like to mention that in response to your request on the channel, I'm doing this IP phones or VoIP configuration lab before my upcoming video on subnetting. So let's explore and learn together. But I would like to mention that one of the brothers on the channel left a comment and requested a VoIP configuration or IP phone configuration lab. Brother, this video is for you. Unfortunately, I couldn't read your name. Your name is doesn't show on the comment. I hope you fix that so in the future I can mention your name. Anyway, thank you for your comment. It's your kindness, brother, and I try my best to make it as easy as possible and explain in detail so you can understand it better. Thank you again. So let's start and jump in without wasting time. As you can see on my screen, I have this topology. This topology is very common and usual that I can say most of the organizations, especially small organizations, they are using this kind of topology in real time, where they have one switch and they divide it for a voice and for data. For data and for voice. And there is one router. The router is functioning as DHCP server, and also it functions as a telephony service server, and also it functions as normal router to accommodate inter-VLAN routing to allow these two VLANs to communicate. So based on this topology, we need some configuration on both router and the switch. On the router, what configuration we need? We need to create sub-interfaces first of all. Because we have two VLANs, we cannot accommodate both the VLANs on one physical interface, so we need to create two sub-interfaces to accommodate or make it possible for both the VLANs to communicate using the virtual interfaces, which is called sub-interface. And then we need to assign IP address on both the sub-interfaces that we create. I decided to use the 10.1 and 20.1. This is a Class C, by the way, Class C IP address, 192.168.10.1 and 192.168.20.1. But they are different networks because the third octet of the IP address is different. So this is different network, but we are using it for both. This 10.1 I will use for the VLAN 10 for voice, and 20.1 I will use for the sub-interface for data for VLAN 20. And then we need to configure two DHCP server pools. This is the step 3 that we need to do on the router. We need to create DHCP pools to provide IP address for PCs and also for IP phones. So we need to create two DHCP pools, one for data and one for voice. And the last thing, we need to configure telephony services to make the IP phones to receive the configuration of telephony service from the router and then function. On the switch, we need to create VLANs. As I mentioned before, I'm going to create VLAN 10 and VLAN 20. VLAN 10 for IP phones and VLAN 20 for computers. And then assign the interfaces to VLANs. So these interfaces that are using right now, that we are using it right now, basically we are using them. Actually there are more than one, so they're like we are using 7 interfaces. So these interfaces need to be assigned to the VLANs, to the proper VLANs, either VLAN 10 or 20. And then we need to configure a trunk port. What is a trunk port and what's the access port? We will explain that while doing the configuration. But to just mention, this interface which is connected from the switch to the router, this is the trunk port. And this interface should allow both the VLANs or all the VLANs that are configured in the switch to communicate with each other using this trunk port. And I will explain a little bit in details about trunk port when we are doing the configuration. So before I start the configuration on the switch, I would like to mention that this video may be a little bit longer than usual. So please stay tuned and watch till the end so you can learn. Thank you again, and let's start the configuration on the switch. So we open the console on the switch and we go to the CLI. CLI means command line interface. And here we need to move from this mode to configuration mode, and then from configuration to global configuration mode, where we can configure or write our commands to configure the configuration we need. So we need to create VLANs, VLAN 10 and 20, and we need to name them voice and data. So to do that, first we need to type the word VLAN, and then we need to type the VLAN ID. So the VLAN ID, first I want to create the VLAN 10, so I type the number or the VLAN ID, and then I name it as voice. That is it. We exit, and then create the VLAN 20 again, VLAN, and then the VLAN ID 20, and name it data, and exit. So now we created two VLANs, VLAN 10, we name it voice, and VLAN 20, we named it data. Now what we need to do, the second step, is to assign the interfaces into the VLANs. Now in this switch we have 24, this is a 24 port switch, and out of 24 ports we are using only 7 ports. Either you can assign these 7 interfaces, or you can assign more interfaces. So in case in the future, if you get more IP phones or computers to add in the network, then you have room, so you already have configured, so you just connect and it will function, it will work without doing extra configuration in the future. So for that, if you have a spare interfaces on the switch, you can go a little bit more. So for that, and also I need to mention this because we have 7 interfaces. Either we can assign them in group, or we can assign them one by one. If we assign one by one, it's time consuming and it will take a lot of time. As a system administrator or network administrator, you don't want to waste time on these things. So what you do, you can assign in group. To assign in group, what you just need one word, which is called range. So interface, then range, and then you type the interface type and number. So interface type, all these interfaces, the type is fast Ethernet, and the number is from 01, from interface 01 to interface 07, or I can go to up to 10. So I can just say 10. I don't need to type again interface fast Ethernet 010, so I just say from fast Ethernet 01 to 10. And then I want to declare the type or the mode of these interfaces as access. So what does access mean? So switch port mode is access. Now I want to pause a little bit here to explain what does the switch port mode mean. So switch port means the interfaces mode, or you can call it interface, or you can call it ports. The mode of these ports are access. When the interfaces are in access mode, that means they can only allow single VLAN to communicate. Either they allow VLAN 10 or VLAN 20 to communicate. So they won't allow other VLANs to communicate. Only one VLAN will be allowed to communicate. So that's the access mode. Now when we declare the mode of the switch ports, then what we do, we assign them to the VLAN that we want. Switch port access VLAN 20. So remember, with this command line, what we did, we assigned all these interfaces from 01 to 10, we assigned them to VLAN 20. But now I need to separate the voice IP phones or the voice from VLAN 20 to VLAN 10. So for that, what I need to use this command: switch port voice VLAN 10. Now this command is telling the switch that you have another VLAN, which is VLAN 10, and that is for voice. And the switch is smart. The switch knows that these are my IP phones and these are connected to these interfaces. It automatically assign the IP phones to VLAN 10. And even in the future, if you connect more IP phones, it automatically assign it to VLAN 10 because of this command. Now we are done. We created the VLANs. We assigned the the interfaces to the VLANs, and now we exit because we are done. And what is the last thing on the switch to configure is the trunk port. So which interface we need to configure as a trunk? The one which is connected to the router. This is the one that is allowing all the VLANs to communicate with each other using this interface. So for example, if I am configuring these two VLANs, VLAN 10 and VLAN 20, and if I want to communicate from IP phones to the PCs, the communication will not be straight, will not be direct from the IP phone to the switch and switch to the PC. First, the request or the package will go from the IP phone to the switch, and the switch using the trunk port will send it to the router, and the router will get the package, will analyze it, and will send it using the proper interface, send it back to the switch, and then switch is sending it back to the PC or the device that is intended for. So that means the trunk is basically allowing multiple VLANs to communicate. So the difference between access mode and trunk mode is that access mode is allowing only one VLAN to communicate, and trunk mode allowing multiple VLANs to communicate or coexist in the switch. So now to create the trunk port, what we need to do, we need to first specify the interface. So we type interface. Which interface is that? This is the gig 01. So we type interface gig 01, and switch port mode is trunk. That is it. We don't need anything else. We just need to declare the type of the mode of the switch port of this interface as a trunk. That's all. So we are done with our configuration on the switch. If you just want to see the configuration, whether we created the VLANs they are created and the interfaces are assigned, we just use this command do show VLAN. So if you see, we have VLAN 10 voice and it's active and the interfaces are configured, and VLAN 20 for data and the interfaces are configured. Now we are done with the switch. We don't need to do anything else. We have to move to configure the router. So to do that, let's open the console and then go to CLI. And here, I don't want to do the initial configuration. What is initial configuration is basically if you say yes, it's asking you to configure the host name and then configure the user enable password and then configure the secret password. I don't want to do all those. I want to skip just by saying no. And then I move to configuration, global configuration mode, and then I start my configuration of the router. So on the router, what we need to first do, we need to configure sub interfaces. But before that, we need to turn this interface up. Right now on the router, this interface is down. As you see, they have red indicator, means it is down. So we need to turn it up first. To do that, we need to type the interface and then interface type and then interface number. Interface type is fast Ethernet and the number is 00. It is this interface which is connected to the router. And then we use the command no shutdown to turn it up. Now if you see this interface, the indicator turned to green, and also here it says that interface status start changed to up. And we can exit from this interface back because we need to create sub interfaces. So for that, what we need to do, again, we need to say the same command, interface, interface type, interface number, and then for which VLAN I want to create this interface. So first I want to create for VLAN 10, so I say .10. And as you see here, it says the line protocol on interface. Basically, the sub interface is status changed to app. It's created and the status app because the main interface we already turned it up, so it's the sub interface is also up. Now here we need to use a command. It's called encapsulation and .1q. Here I would like to pause and explain what is encapsulation and why we are using it to make it easy for you to understand. So encapsulation .1q, it's also called as IEEE 8021Q. It is used in computer networking basically to implement virtual VLANs. It adds a tag to either Ethernet frames, allowing multiple VLANs to coexist on a single physical network and keeping the traffic separate. So basically, it is doing the same job as a trunk mode we did on the switch. The encapsulation allowing us to have more than one interface on the on the router to basically create sub-interfaces and allowing multiple VLANs to create to communicate using those sub-interfaces. And now we type the encapsulation.1q and then the VLAN number, and then we configure the IP address. IP address is 192.168.10.1. So for VLAN, remember, for VLAN 10 and for subinterface for VLAN 10, I'm using the 10.1 IP address. And then the subnet mask for this IP default class C is 255.255.255.0, and that's it. And exit from here. And we now configure another subinterface for computers for data. So we use the same command interface fast ethernet 00 and then 20, because this I'm creating for VLAN 20, and then encapsulation dot 1q and 20, the VLAN number, and IP address is 192.168.20.1 and 255.255.0, and exit. That is it. Now we completed the step 1 and step 2. We created the sub-interfaces, we assigned the IP addresses, and if you want to confirm that, you just type do, because always remember, when you're on the global configuration mode, before the command, you always use this word do. Do show IP interface brief. Now if you see here, we have two sub-interfaces, .10 and .20, and the IP addresses are assigned, and they are up and working perfectly fine. Now, the third step is to create two DHCP pools, one for computers for data and the other one for voice. So let's do that. To create DHCP pool, we type the IP command ipdhcp pool and we name it. So first, let's create for data, so we name it as data. And now, what is the network that I want to use for this DHCP pool? So the computers will get the IP address, will obtain the IP address from that pool or from that network. So that network is, I'm saying network 192.168.20.0. So remember, we used this IP address for data interface that we created for VLAN 20 for data. And now we are using this network. 20.0 is basically the network, because remember, in class C or any class, changing the host address to 0, it converts the IP address to network address or network ID. So instead of this 1, we are using 0, and that converted to the network. That means include all the IP addresses in this network. So the network is 192.168.20.0 and the subnet mask is 255.255.255.0. And now also I need to configure the default gateway for these PCs. So the default gateway for this PC is the IP address of the sub-interface that we created for data. And that is, to do that, we say default router means default gateway, or is 192.168.20.1. That is it. Our DHCP pool for data is completed. We don't need any other extra command. Only we need if we want to exclude IP addresses that we don't want to assign. But in this case, we don't want to exclude any IP address, because we only used one IP address from this network, that's 20.1, but that's default gateway, so it will not be assigned to any computer, because this is the gateway. Other IP addresses are open, and the computer can receive any IP address from 20.2 to 20.255. So let's turn on the DHCP on the computers to make sure that they receive the IP address. So open the computer, go to IP configuration, and then DHCP. and this they should receive. Yeah, perfect. This received DHCP request successful and received 20.2 and the gateway is 20.1. So let's go to the second PC and do the same thing, and this should get the 20.3. Perfect. And let's do the third one, the HCP on, read DHCP request successful 20.4. Perfect. That means our configuration was fine. Now we need to create another DHCP pool for our IP phones. So the same command, IP DHCP pool, but this time not data, it is voice. The name doesn't matter, you can name any name. It doesn't need to be data or voice. You can name it any name. This is not necessary. But what is important, the configuration, the command line that you're using. The name is not important. I'm using it just for the sake of this practice. So the same thing now, network is 192.168.10.0. So remember, I used 20 for data and 10 for voice. So I'm using again the network ID, which is 10.0, and then the subnet mask 255.255.0. And again, I'm telling or configuring the default gateway for these IP phones, and that is default router is 192.168.10.1. So this is the IP address of my sub interface, which I created for the VLAN 10, and that is the default gateway for the IP phones. And enter. And remember one thing which is very, very, very important, and there is no room for mistake on this one. So when we are configuring DHCP for IP phones, we need to use one extra command, and that command is option 150 and then the IP address. IP is 192.168.10.1. So I would like to pause here a little bit because most of people have confusion about this, why we are using this option 150. So this option 150 is basically specifying the IP address of the TFTP server. What is a TFTP server? TFTP server is a server that provides the configuration file to the IP phones. So when the IP phones are booting up, this TFTP server is providing the configuration file. What is the configuration file? All these configuration that we did right now. The IP addresses, the last configuration that we are doing, the telephony services, all these will be provided by the TFTP server. If we have a TFTP server separately, so we need to mention the IP address here. But in our case, our TFTP server is the router here because all our configuration will be inside this router. So that's why we mentioned the IP address of the sub-interface that we created for the VLAN 10 for IP phones. Because through this sub-interface, the router will provide the configuration file to the IP phones. So that is why we are using option 150 IP 192.168.10.1. If we don't use this one, IP phones will never receive IP address, will never receive the configuration file, so it will not work. And that is it. We only needed one extra command while configuring DHCP pool for the telephones, and that is it. We can exit from here, and now let's our IP phones are not on, so they are off. We need to turn them on to make sure that they receive IP address and they receive the they're in the VLAN 10. So to do that, let's go to first IP phone, get this adapter at the very bottom right and plug it here at the bottom, and then you can use you can go to the GUI, means graphical user interface. So you can see here it says configuring IP. It will take sometimes, if you want to do fast forward, sometimes it makes it faster, and if it receives the IP address properly, then it will say configuring CM list. Perfect. So that means this IP phone is now waiting for line number that we need to configure the line number using the telephony service, and means our DHCP configuration was correct. Now if we want to make sure, so if we go here and if we put your cursor on the phone, here in the small menu it's telling you that it is it is the VLAN 10 is up and the IP address is 10.2. So it received the IP address from the network 10, which we wanted, and it is the 10.2, which is perfect. Now we can turn on all the IP phones. So plug the adapter, turn it, close it, and I do the same thing for all these IP phones. And that one we have here, which is separate. Perfect. Awesome. So we are going to do the last configuration, which is configuring telephony service. So to do that, we simply, to enable that service, we type telephony service. Telephony service. This is only this line is used to enable the telephony service. Now, the second line is, or the second command is, we need to declare how many IP phones we have in the switch. By default, we can configure up to 42, but in my topology, I have only 4. As I said earlier, while assigning the interfaces to the VLANs, I mentioned that if you want to go a little bit more than what you're using, that gives you room. So in case if you add more devices in the future, you don't need to do the configuration again. The same applies on this command. So if you want to say maximum or max ephone, right now I have 4. I can say 4, but I can go up to 10, because if I want to use in the future 10, then I should have no problem to add or connect. And then I need to declare how many directory number or how many line numbers I want to have. So 4 is compulsory. I need to configure 4 because I have 4 IP phones, but since I said I want to have maximum 10 IP phones, so I will use the 10 as well here. And the other thing is the IP source. I need to say the IP source address is, what is the IP source address for this telephony service, and that is 192.168.10.1, and the port. So the port you could use from 2000 to 9999, I believe. We can check that by a question mark. Putting a question mark here, you can see that the port you can use is 2000 to 9999. So you can say port, I can use the 2000, the first one. So, and then auto assign. We use auto assign to automatically assign the line numbers on the IP phones. So we can say 1 to 10. I have 10 IP phones, so I can say auto assign 1 to 10. We don't have 10 IP phones. We just declare that we're gonna have 10, so that's why I'm going. But in my case, I'm not going to assign automatically. I will assign manually by myself, so I know which number I assigned. And we are done with this. We close here. So what we need to use to configure telephony services, the first command is telephony service, telephony-service to enable the telephony service. Then we need to declare the maximum ephone or IP phones, and then maximum directory, and then the IP source for this IP phones, and then we need to use the command auto assign, and now we need to assign the directory numbers or the line numbers, the phone number basically for these telephones. So for that we need to use this command ephone -dn. So dn means directory number, 1 means for the phone line 1, and then we say number is let's say we start from 2001 and exit. Now ephone, and that was registered, so that's perfect, means our configuration was perfectly fine. Now we say ephone dn dn2, and number is 2000. Exit. Now ephone dn3 ephone -dn3, and the number is 2000. We use 2002, so we use 2003. Exit. Now we have one more, so we use ephone dn4, and number is 2005. And let's exit. And now let's see whether these numbers are assigned or no. So you see this telephone, or this IP phone, got the number 2003 or 2003, and this one is 2005, and this one is 2001, and this should be 2002. So perfect. All our phone lines got the line numbers, and now we can test the configuration using the graphical user interface of the IP phones, and then we can dial the number and ring and see whether they work or not. So this IP phone has the line number 2001, and let's see this other telephone. This has the 2003. Now let's dial from this phone on the right side, this phone 2001. So 2001, and then pick up the handle, and you can see it's ringing, and the flashlight it's flashing. That means the configuration was perfectly fine, and they are communicating. Now let's close this and open other line. So let's go. This is the 2005. Now so let's dial from 2005 to 2003. 2003. And if you see, it is perfectly working fine. They are working and they are ringing. Awesome. So now means configuration completed, and we were able to ring the IP phones, and they're working fine. Now let's test the communication between the PCs and the IP phones. As I mentioned before, because we are using a router and we used encapsulation, so the communication between the two VLANs should be possible. If you don't have a router, then the IP phones with the computers will not be able to communicate. But in this case, they should be able to communicate, but it will be a little bit lengthy process, because if I send a request, let's say a ICMP or a ping request, so this should go back first to the switch. From switch it should go to the router, and router will use the IP and VLAN ID, and then it will route it back to the VLAN ID using the sub interface which is configured for that VLAN, and then send it back to the switch, and then switch send it to the this side to this VLAN ID or the device which is in that VLAN ID. So let's see how it works. Let's go to simulation. In the simulation, I'm going to edit the filters. So I don't want to use all these packages. I don't want to make it very heavy package. So you just use the ICMP or the ping package. So I unmark all these other packages. And then I don't want to use constant delay as well, so I want to make it faster. So I get a package, drop it on the PC 0, and then drop it on any IP phone, let's say a IP phone 5, and just play it. So as you see, the package goes to the switch should send it to the router, and the router should send it back to the switch using the interface, the sub interface, which was for VLAN 10 for voice. And now switch got it and understood that this is for this VLAN and send it to the IP phone 5. And now IP phone 5 should send it back to the switch should send it back to the router, and router should send it back to the switch, and switch should send it back to the PC. That is how inter-VLAN communication works, and that's how the router works. Without the router, this communication between the VLANs will not be possible. And if you see the communication was successful and we got that check mark here, and that means um, it is working fine and our communication was, configuration was successful. I hope it's not too long. Thank you again, everyone. Thank you, brother, for your comment again. I wish you all a very good time with your families. Stay safe, and please make sure to write your feedbacks and comments on the channel. I will really appreciate your comments. That your constructive comments will definitely make improve the channel and improve me. And if you want me to do something differently, please make sure to write your comments. I will definitely open to uh, change for positive. Thank you again. Stay safe and healthy, and please consider subscribing and liking and writing comments. Thank you again.